This unit is a short survey of the linear model landscape in machine learning. We have mentioned the guiding principle: start simple, then iteratively move toward more complex solutions. This principle is particularly important for the modeling part of the AI's enterprise workflow. When referring to a simple model, linear models are often what is implied. However, there are simple forms of linear models like simple linear regression and far more complex ones that include splines, basis functions, regularization, and more. The essential thing to understand is why it is important to start with a simple model in the first place. After all, linear models rarely compare favorably to the predictive performance of neural networks or tree-based algorithms. There are several reasons we start with simple linear models, but a commonality is that simple models serve as a baseline to help calibrate understanding. In this context, understanding refers to why the model performs well. If we compare a simple linear regression to a penalized form of the same model, for example, ridge regression, then the difference in performance between those two models can help build intuition. If we use logistic regression and compare it to a complex neural network, and there is no appreciable difference in predictive performance, then we would default to the simple model because it is easier to train, easier to interpret, and easier to communicate. Additionally, if a more complex model fails to outperform the simple one, this may also indicate problems with the underlying signal in the data. The other important reason to start with a simple model is to build an intuition for the business impact. For example, an increase of 5% in F1 score is expected to help your business by how much? If we were interested in predicting churn at a Vail and we implemented a promising boosting model, maybe the F1 score is 0.95 and that month's revenue went up by 1%, but we are left with very little intuition. Letting a simple model that has a high level of interpretability run for the first month can provide crucial insights into what data are important, and it will provide a baseline that will allow you to make statements about the expected impact of a new model before it is deployed. It is not always a possibility to deploy a simple model before the more complex ones, but the gain in intuition can be important when it comes to prioritizing projects. In this unit, we will focus on the use of pipelines as a way to implement predictive linear and logistic regression. There will be an example that illustrates the elastic net, a generalization of ridge and lasso regression. Finally, we will discuss linear models through the lens of generalized linear models, or GLMs, followed by a survey of linear model extensions, including basis functions and splines.